In this video, we will see the implementation of the microwave problem, the initial implementation. So let's first run the program and see how it behaves. So this is the graphical user interface that we see when we run the program. There are three buttons here. Since this is not a physical microwave, we need some way of closing the door and opening the door. So they are simulated by buttons. So if you press close door, it is supposed to simulate the closing of the door, and this would open the door. And the cook button is here. There are some displays here that show the microwave's actions, like it says the door is closed, the light is off, 0 time for cooking to end, that is basically not cooking. And let's see what happens. Right now the door is closed, so we can actually cook. And in the specifications, we had said the microwave will cook for 1 minute, but just to help us speed up stuff a little bit, we will, in this implementation, cook only for 10 seconds. It is very easy to change that 10 to 60. So that is not a huge issue. So let's cook. And you can see that the counter is going down and it is saying cooking, light is on, 3 seconds left, and cooking is over now. Okay, let's try this again, cook, and we press cook again. You can see that the counter is increasing, like I keep pressing this and now it is 100 seconds and it keeps going down. Let's not wait for cooking to end. It says door closed, light on, 93 seconds left. It is cooking. Let's open the door and the light is on, the door is opened, 0 seconds left, not cooking. Let's close the door. And we can continue doing this. There is not much that we haven't seen yet. So let's see how the microwave program is constructed. As I said before, the first solution, the initial solution, is very simple, very done rather quickly. So what we do is we proceed as in the case of the library, looking at the requirements and picking out the nouns. And we see things like microwave, power tube, light, display door, etc. And we make a quick assessment of the situation. The graphical user interface, as we have seen, should contain the cook button, and the door will be simulated by buttons. The status of the power tube and the light, the time needed to complete cooking are all through messages on the graphical user interface. And we need something to simulate the microwave, and we need a timer. So the microwave will keep track of what the oven is doing. Is it cooking or not? It has to keep track of what the status of the light is. It has to listen to clicks on the buttons for opening and closing the door or request to cook. It has to also listen to the timer as each second ticks. And the GUI display, as we have seen, has components for input, and it also displays the various statuses. I would encourage you to take a look at the video, the previous part of this video, to see how it behaves. The program is also available on D2L, so I would like you to take a look at that too. And the clock generates a clock tick at regular intervals. So this is what the graphical user interface is doing. We can have a very sophisticated graphical user interface that looks very much like a microwave, but that requires a lot of work. So instead of that, we are having a very simple GUI, as you have seen. But instead of shutting off any further possible extensions to the GUI, what we have done is have an interface that says what the GUI should be doing. You can have this specification implemented in a very elaborate way, which we are not going to do, or in a very simple way, which we have done. So no matter what kind of display you have, it has to show the time left. It has to turn on the light on and off. And then it has to open the door and close the door, and show the cooking process and show that it is not cooking, etc. So we are not going to have anything very elaborate as we have just seen in the display. And let's see how things are going to flow a little bit. We are going to have a clock object that keeps ticking. It continues to tick right from the time the microwave program starts, the whole system starts. And whenever it ticks, it sends a message to a microwave object. So microwave is a class and the object is microwave, and there is a graphical user interface which we call display. The class is called GUI display, and when the clock ticks, we call this method clock ticked in the microwave, and we have a conditional here. If it is the case that the state is cooking, if the clock is ticking, it only matters if the state is cooking. If the door is closed or open, it doesn't really matter. And if the state is cooking, the microwave knows that 1 more second has elapsed. It shows the time left. So if it was like 30 seconds before, now it is going to be showing 29 on the GUI display. And we have another conditional here. If the timer runs out, that is the microwave, shows that it is not cooking anymore on the display by sending a message, and it turns the light off. And after that, control goes back to the clock. So that is an example of something that happens within the system. Another example, when the user opens the door, the GUI display is the one that senses it. That is how it is constructed, right? And the GUI display will send a message to the microwave saying that the door has been opened. So that is a method in the microwave. And the microwave would then decide on a few things. It has to show that the light is on, that the time left is 0, that the door has been opened, and it is that it's not cooking anymore. So all those pieces of information are sent to the display through method calls. Now it is time to start looking at the code. So instead of looking at the PowerPoint slides, I will show you the Eclipse code. Now, let's look at this class, clock. Some of you may know what a thread is, and others may be unfamiliar with this concept. So if you are not sure what a thread is, you should watch the video that I will be posting about threads. If you know what a thread is, you can skip that. So once again, if you don't know what a thread is, please watch that video before continuing with this video. So I assume that at this point, everybody knows what a thread is. That is, people who did not know what a thread was have watched that video, and then kind of understand what the basic concepts are. So in Java, you can create a thread in two ways. One is to have a class that extends the thread class, or you can implement an interface called runnable. So the approach that we are taking here is to implement the runnable interface. And public class clock implements runnable. And here, the clock constructor is private because there is only one instance of the clock. So this is implemented as a singleton. And we create a thread out of this runnable by creating a thread object using this clock object. So new thread creates a thread, and the thread is based on this clock object. So we pass this, whatever this clock object is, and we start the thread by calling the start method of the thread class. So this creates a new thread out of this clock object, and it will eventually call the run method. So although the application is calling the start method of thread, the start method will call the run method, and you can see that there is an infinite loop here while true. What we are doing is we are sleeping for 1 second. Thread.sleep is a static method in the thread class, obviously, and it takes in a parameter that says how many milliseconds execution should pause. And we are saying it should be 1000 milliseconds, that is 1 second. And after a second, the clock object calls the clock ticked method of microwave. Microwave is another singleton, and its instance method is called in the constructor of clock to get the microwave object. So microwave.clockTicked calls the clockTick method of the microwave object, and we have seen what happens within that method in a sequence diagram. The sleep method can throw the interrupted exception, so you need to catch that over here. So this is in an infinite loop. The run method is in the runnable interface, so you need to override that. So that is the clock class. It essentially runs forever, sending a message to the microwave every second. Then we have the class GUI display. You can see that it is a JavaFX program. It implements microwave display, which we saw in the, at least the UML we saw earlier in this video. And it responds to clicks on the button. So it implements this interface. It has buttons for door closer, door opener, and cook button. Then it has text for showing the various aspects of the microwave, and it is a singleton. And here is the code for creating the graphical user interface. And the methods of the interface are implemented here, and they are very simple. They simply show what the status of the microwave is with respect to the light or the door and stuff like that. So there is nothing very difficult about these methods. Slightly more interesting method is this, the handle method for implementing this interface event handler. So when a button is clicked, control comes here and we get an action event. The event could be because we clicked the door close button, door open button, or cook button. For each one of those events, we have a corresponding method in the microwave class, which we will see next. And we call the corresponding methods. Okay. The microwave class is here. It is also a singleton, as we have seen in the through the clock class. Let's see what the fields are. There are three possible states, as we know from the state transition table: the door closed state, door opened state, and the cooking state. That state is stored in this field, current state, and it is initially set to the door closed state. So when the microwave starts, the current state is door closed. The time left for cooking is 0. The microwave class, of course, is singleton, so we have this instance field, and it stores the microwave display object. That is this. Now, some initial work is done here. And after that, we have one method for each event. What if the door is closed? What if the door is opened? And what if the cook button is pressed? Those are events that can happen from the outside, external events. But there are internal events, and that internal event is clock ticked, as we have seen. So there are methods for each event except the internal event. When the clock is ticked, we check what the current state is, and if it is cooking state, we do some stuff. And if the time left is 0, we do realize that the cooking is over. So that is an internal event generated within this method. Okay. So let's examine the methods for processing each event. When the door is closed, it only matters if the current state is that the door has been opened. Otherwise, there is nothing to do. If the current state is door open, the current state is now door closed, and you tell the display to show certain things like that the door has been closed, it's not cooking, the light is off, time left is 0. Okay. Then if the door is opened, we need to change the current state to door open state. But if the current state is already door open, there is nothing to do. But if it is door closed or cooking state, we need to be within this conditional, and we set the display accordingly. If the cook is requested, we ignore it if the door is open. But if the door is closed, we go to the cooking state and show the appropriate things on the display. But if it is already cooking, we add some time to the time left. Time left keeps track of how many seconds are left to end the cooking. Initially, we set it to 10 just to make it easier to test. And we add 10 seconds for each press of the cook button afterwards. When the clock is ticked, the clock object calls this method. And if it is the cooking state, we decrement 1 from the time left field and show that. And if time left is equal to 0, we change the current state to door closed state, and we show the appropriate messages on the display.